can you see my slides, sir, coming up?
Yes, sir.
Okay, fine. So I would talk to you on these three keywords: IoT, Internet of Things, cloud, then big data. How all of them are connected together and how to develop models using all these three together. So this is my official affiliation. I work with Amrita School of Engineering, Coimbatore campus. First, let's come into IoT, Internet of Things. All of you know what an IoT is. Interestingly, people say that if I have data coming from different devices, and the devices can be systems or it can be sensors, then I can do some end-to-end processing on the data. For example, if I have a camera at my home, and let's take I'm at a remote place and somebody is in front of my door at my house, my camera data is an example of an IoT application. If you have a sensor in my door and that door can actually pick up the camera face, and let's take it as person X, the door can open automatically. That is also an example of an IoT application. So IoT, as the name indicates, Internet of Things, is a system of interrelated computing devices where there can be a mechanical component, where there can be digital machines also together. And the interesting thing is we are interested to do some sort of interaction and end-to-end processing with the data that we get from this IoT. So this is an example of an IoT system. So first step, what we want is we want to just do some collection of data. So people will say, I want to collect some data. So one answer would be like, people say I'm collecting data from sensors. People say I'm collecting some data from antennas. I'm collecting some data from microcontrollers. So one, if you say you are trying to have some data, then people say that you need to build some sort of an embedded system device. So that embedded system device can be having a microcontroller and it can have onboard sensors through which it can collect the data. Once the data is collected, then the next question we want to do is we want to transfer the data. What is this transferring of data is, if you look at a networking perspective, people say that if you have a set of computers and the computers can actually do some processing, then the next question somebody would say is like, you can have some sort of networking devices which will transfer the data. Here again, when you talk about an IoT application, people say that I have an IoT hub or I have an IoT gateway through which I'll be able to transfer the data. Once the data is transferred on the end user side, the end user as such wants to do some analysis with the data. This analysis as such can be helping us to do some sort of analytics also. For example, somebody as a layman would say, how many people have entered the room, right? It can actually be dependent on the camera data that is picked up from a remote place. So you can analyze some data and you can do some analytics on it, right? The advantage would be like you can take some course of action with the data that is being analyzed. So this is an example of an IoT system. So first we need to collect some data. Then the second step, we want to collate and transfer the data. And third step, what we want to do is we want to analyze the data and take some further action. So why people are talking about IoT for an organization? The advantage is like one, people want to improve their business process, right? So with whatever data you gather from an IoT application, it can help to improve your business. Second is it can help you to improve the customer experience. For example, let's take you run a cake shop, right? And there are 100 people walking inside your cake shop on a day. Now you would like to know how many people are happy with eating your cake, right? So that's an example of a customer experience, right? So next is the benefit of IoT is to save some money and time also, right? Wherever you are interested for an human monitoring, instead of a human monitoring, you are trying to build a system that will monitor, right? For example, let's take you keep some person who will actually monitor the animals in an area, right? So you're going to pay something for the person, right? Every month. Now, instead of it, if you keep a camera there, the camera can actually pick up the data and it can say whether there is an animal coming into that place or not. So there's a lot of saving of time and cost, especially with respect to money, if you're going for an IoT. The next is enhancement of employment part, right? If you have employees and the employees are involved in doing some sort of an packing, right? For example, if there's a set of products getting created and the products are packed, right? So instead of having more employees, you can have less employees and that employees' productivity will increase because an IoT will take care of enabling the packing part also parallelly. So all in more, we are trying to say here is an IoT will help you to improve the business and will bring back some more revenue to your organization. I'm talking to you as a basic level, then I'll come back to slightly to the advanced part. The next is people ask you a layman's question, what are the IoT standards, right? You want to set up an IoT application, all that is fine. What are all the IoT standards? The first IoT standard in theory is IPv6, right, which can be used for wireless personal area networks. Second IoT standard is ZigBee. As far as ZigBee is concerned, it is said to consume low amount of power. So it's called as a low power, low data rate wireless network. Then next is LightOS. LightOS is something like an Unix operating system, and it is more used for any sort of sensor networks. Then next is one M2M, which is actually a mission-to-mission service layer embedded device, which can be used for most of the IoT applications, right? And next is DDS, that is Data Distribution Service. This has been developed by a group called as Object Management Group, and this is more towards mobile-to-mobile communication. The next is AMQP, which is Advanced Message Queuing Protocol. It has been set as an open standard, and it is used for client-server applications where there is IoT devices. The next is Constrained Application Protocol. This has been defined by the IETF, Internet Engineering Task Force, and it has been used as a most common standard for IoT applications. The next is LoRaWAN, which stands for Long Range Wide Area Network. It is a protocol that is designed for applications which are going to work for smart cities, right? So these are all the different IoT standards that are there. So next question would be like, what about the IoT framework, right? So people say that I have got an IoT application, right? So can I actually test it in some platforms? So one, you can actually go for Amazon Web Services, or you can go for ARM Embed, right? Which is used for ARM microcontrollers. The next is Microsoft Azure IoT. This as such will allow you to interact and receive data. And the advantage of this Microsoft Azure is it is said that it has got more amount of visualization of data. The next is Google's Braille is there. It is also a platform for IoT applications. And next is Kelvin. It's also an open source platform which is developed by Ericsson. So these are all the IoT framework that are existing. So what we have seen is, we have seen what is IoT standards. We have seen what is IoT framework. Now next comes the question of your visualization, right? People say that I want to visualize some data, whatever you have in your IoT. Can I visualize it, right? Yes, it is possible for you to visualize your IoT applications. So if you go to your browser and type ThinkSpeak, you will get this URL, which is ThinkSpeak, which is actually a complete platform for IoT analytics. Okay, if you want to do some analytics on the IoT data, please use this ThinkSpeak. It will give you a lot of visualization of data that is collected through your platform. Okay. So next is going to be the programming platforms, right? So which programming platform can I use for an IoT application? So one is Zeta is there, then you can use Arduino, and there are many other platforms that are there proposed, right? So these platforms as such will are giving you one step forward to say whatever you code can be made as a complete product. I'm again repeating, whatever you code can be made as a complete product, right? That's the thought of this IoT programming platforms. This is an IoT solutions architecture. Please listen, all of you. One, you can see here in stage one, you can actually look at what are all the sensors and actuators that are required. It can be wired or it can be wireless. In the sensors and actuators, you can also see cameras are also coming up. Then second, what you see in stage two is internet gateways and data acquisition systems. What is this internet gateways or data acquisition systems is? Data is coming from different sources, right? Here it is called the sensors, right? So data is coming from different sources. Now your requirement is you want to combine all this data and you want to do some processing. So ideally what you want to do is a data aggregation part, right? So here it is might be required that you will have to convert some data which is in analog to digital form. Even for your information, we have cameras which are analog cameras, right? It need not be digital cameras. So you have analog cameras also. So there is a need for conversion from analog to digital also. This is stage 2. Stage 3 is basically where you want to do the analytics. Here people talk about something called as edge analytics. What is analytics would be is like a smallest analytic would be is like I'm just presenting a histogram, right? I'm putting a scatter plot. All that are examples of analytics. When you say edge analytics, it will be slightly different. It means that you are bringing the computational capabilities more on the device level. For example, once your device is acquiring your data and it is trying to do some sort of processing, there you can bring visualization at the device level capability itself, which we can call it as an edge IT analytics. Fourth is stage 4. This is what is very important with today's session also. Whatever data that you have, right, you can push the data to the cloud. On the cloud, you can do the processing, right? Whatever data you have, you can push it onto the cloud, and on the cloud, you can do the processing. So these are the 4 stages of IoT solution architecture. Any problem that you want to create, right, first you need to think about how you are going to generate the data. So data needs to be created by measuring the data through some sort of input devices. So the input devices can be sensors or actuators. Once the data is measured, right, then that case, then the next step is you would go for internet gateways. Third stage would be is you are interested in doing some analysis, which is edge analytics. Fourth stage would be is like you are interested in setting up a data center, which can be built on cloud. So the cloud can actually have the data, which is built as part of the application, and the cloud as such can have the capabilities to do the processing also. Now, this is the overall picture from the research perspective. You need some data source, right? Okay, for doing your IoT problems. So the data has to be collected. So first step is like you need a good data source. How will you get your data source? The data source can be part of any sort of sensors, or it can be cameras, or it can be any sort of devices which can actually capture the data. Once the data is captured, right? Once the data is captured, it can be on the cloud, right? And from the cloud, you can actually have your models to run. And these models are going to run with different algorithms. The algorithms could be basically on machine learning. The algorithms could be on deep learning. The algorithms could be on data mining, right? Finally, what you want to do is you want to do some analytics. So at one point, each of you will accept with me saying that whatever is the data that you want, first you look at how the data is going to be sourced. So you need to first gather your data. So gather your data through that some device. Now build your data. Now the data is in the cloud. Fine. On the cloud, you actually run your algorithms. So the algorithms will give you some sort of prediction, and you can do some analytics, right? So this is the overall picture of how you can connect all these 3 keywords, that is IoT, cloud, and big data. And since this data is going to be quite large in size, we can call the data to be a big data here. So next question somebody would ask is, okay, can I actually take some data sets on the internet? There are many data sets on the internet. Usually I suggest Kaggle dataset, right? And this is also a good link where you can actually have your data sets. This link as such will show you many data sets which you can use for deep learning with IoT. I think you can see here. It's a very popular link. In this link, you'll find different type of data sets which are being available, and they'll be archived to each of the data sets. For example, somebody says that I'm interested in working with an agricultural data set, right? So there, the pre-captured data set which is being created from the organization, right? That's your CGI, right? So they actually have the data set here, as you can see here. They actually have the data set. So you can actually download this data set and you can use it for your research. Okay, so this information is for research community to know. These are possible data set sources, right, which you can use. And next is today's research direction is also looking into something called as web services. Can you use web services in IoT for doing analytics? Yes. Their answer is AWS has created a facility for doing IoT analytics, right? Which they call it as AWS IoT analytics, right? This is and another useful URL people can go through, right? AWS IoT Analytics for IoT devices. So you can actually get a free access. You can try accessing this URL for getting a feel of what is Amazon Web Services IoT Analytics. Sir, am I audible?
Yes, sir, audible.
Okay, fine. Now the next question somebody would ask is, okay, all is
yes,
fine.
Sir, audible, sir, your voice is audible.
Okay, thank you, ma'am. Thank you. When somebody would ask is, okay, now my data is there. Now I'm interested in setting up a real framework. Okay, how do I do my framework part? So their answer is you can go for setting up your framework on cloud. The cloud framework could be either proprietary based. There you can go for Amazon, right? Or you can set up a Google Cloud, or other possibilities like you can go for an open source cloud, which can be built on Hadoop, or it can be on Spark. When you look at this, people suggest to go for either Java, or you can go for Python also for setting up and working with Hadoop or Spark. Now, let's come to the discussions with respect to the cloud. Now, what are we now traveling is, we have seen what is IoT. We have seen IoT framework. We have seen IoT standards. And from there, we are now coming into the next important concept of how to set up a Hadoop framework. Yes. Okay. See, when somebody says they are going for a cloud, then the other question somebody would start complimenting or asking again is, why you should go for a cloud? You can actually go for a distributed computing itself. Cloud is a solution, but why is cloud? The answer is very simple. A cloud as such has the capability of managing the task among themselves whenever there is a node failure, right? Let's take 10 systems are going to work together as a cluster. One node becomes a failure. That means the one node is not working at all. So the remaining 8 nodes will automatically communicate among themselves, and they will do all the operations as if the 9 computers were working. This is not possible in the case of distributed computing. Please understand this. This is the strength of cloud. So cloud strength is very simple. Wherever there is a point of failure, the remaining nodes in the cluster will coordinate among themselves and they will complete the task. This is not possible in the case of distributed computing applications. Now let's come to the next discussion about how to set up a cloud. Okay. Usually this is a very good link for people to go through from Micronaut, where you can actually see the procedure for setting up a cloud. I'm just walking through so that you understand, okay, it is possible for you also to set up a cloud, right? So once somebody is interested to set up a cloud, then they can actually code with Python, or you can go with Java. In case you're going for Java, you have to install your Java packages, right? Which you will get it from your internet. Then you can download Hadoop from this link, right? Once you have downloaded Hadoop, then the next step that you need to do is you need to set up your firewall configurations, right? So for setting up your firewall configurations, you can actually go to your system, and if it is your system, it will have a directory called as etc. Under that, you can go for IP table status, right? And you can check all this here. So all these ports will be there under this table, right? So you can go on just to disable this, right? Originally, it will be on. You can just set it as off in case you want to configure firewall. This is not a compulsory step. If you want, you can do this procedure. The next step would be is like you need to actually create users, right? So wherever you want to create an user, you can actually first start creating a group, because users are as part of the group, right? So the command will be group add. Then you have to give a keyword as Hadoop. Then you can say user, right? So once you say it, then after that next line, you can just type user add -g Hadoop space user, right? And you can just specify this and give the username. So automatically an user by name Hadoop, please understand here, an user by name Hadoop will be added. It asks for the password for the user. You can type the password. Automatically now the user is created. Once a user is created, then the next step would be is like you are saying that you are going to have your local cluster for communication, right? Okay. So here we follow through a public key authentication. So what will be this public key authentication is every node in this cluster that you're going to set up will generate a public key and a private key, right? Okay. So each node, whenever they want to communicate with each other, the node will have the public key of the other user. For example, node B wants to communicate with node A. Node B will have the public key of node A, right? Since node B has the public key of node A, their node A is said to be a trusted node for node B, right? Here, to make it more better, people talk about understanding, saying that the nodes are going to be master nodes and slave nodes. There's something similar to saying that a master node is a server node and a slave node is going to be a client node, right? Master node is going to be your client, master node is going to be a server node and slave node is going to be your client node. Now, the next step, what we do is we need to generate keys for communicating among the nodes. So the procedure is you can use this command ssh-keygen-t space RSA. RSA is your security algorithm. Now a key will be generated and the key as such will be stored as part of this file under the folder .ssh, right? Okay. So this key is going to be the key which is going to be used for authentication among the cluster nodes, right? Then next, what you need to do is you need to type this command. This command, what it is going to do is it's going to add the key that you have created. The previous step, what you are doing is you are just saying SSH-key-t space RSA. Now the key that you have created should be added as one of the public keys, right? And it should be an authorized key for the nodes. So to add it, so what you do is you specify this command, then next line you will specify this. And now the key that you created is becoming one of the master key for communication, right? Last would be like you need to create a folder for making your Hadoop working. So you know your command generally for creating a directory. So you just say make mkdir, and Hadoop is a folder into which your Hadoop would have got extracted, and you can create a folder called as project, right? Now, next step would be like setting the environmental variables, because Hadoop is a third-party package. Java is existing separately. So you have to set the Java path, right, and the Hadoop path, right, together. Now, whenever you are trying to run your program, the program path will actually set to the Java path that you have created. The next is you need to configure 3 files, okay, which is required. One file is called as core-site.xml. The next file is htfs-site.xml, and third file is called as mapred-site.xml. Don't ask why. These are all part of the Hadoop community developers. You'll have to set up all these 3 files, core-site, then htfs-site, and third is mapred-site, right? Now, once you set up all that, then you can actually associate your node with one of the slave node to the master node, right? For that, this is the command. Then you can start your Hadoop. This is the command for starting your Hadoop. So you say Hadoop name node -format. Then you want to start all the services which are there for Hadoop. So you just say start -all.sh. So this is a shell script which is already there. Then similarly, you can actually start your MapReduce job also by just saying start -mapred.sh, right? Now, if you go to the browser and then type http/, right? You can give your IP address name node 500070, right? So 50070, if you type, you'll be able to get the status of distributed file system. If you want to get the status of job tracker, just type HTTP, the IP address of your machine, then say :50030. If it's for task tracker, you can just type HTTP://50060. Now what you are able to do is you are able to get the status of all the 3 applications. One utility is your Hadoop distributed file system. Second utility is your job tracker, and third utility is your task tracker. Now, what is job? What is tracker, right? So people should understand, right? When you want to do a task in your cloud environment, what you're doing is you're splitting your task across the multiple nodes. If you want to count 10 numbers, right? And you have 5 nodes in your cluster. So what you do, each node you give 2 numbers. Finally, you get the sum of all the 10 numbers together. So the same concept is followed here. When you are trying to split the task to all the 5 nodes, there who is going to track the job is going to be the job tracker. To check the status of the task that is given to the individual nodes, what we use is the task tracker, right? So these are the 3 things that you have to monitor every time. That is HTFS, job tracker, and third one is the task tracker. So once you have done like this, it is something similar to what we are trying to show you here. This is your individual nodes, right? And the nodes are connected with your networking devices. Fine. Nodes are connected with your networking devices, and they again can connect to the switches, and they can connect to the storage devices, right? Now, this is what we saw from the previous slide, okay? From this slide. Now, this is connected to the external world by using a firewall, right? Now, if you say this is your cluster of Hadoop, so what does it mean? I've installed Hadoop software. Each machines are having Hadoop clients, right? There are 3 processes running. What are the 3 processes for our learning? One is HTFS, then job tracker, and third is task tracker. All of the 3 are running in the individual nodes. One is a master, one is a slave. Now, you can actually add any number of nodes to this, and you can try to say that you have established a Hadoop cluster, right? Now, when you do like this, what would have happened is you would establish your Hadoop cluster for your learning. Why cloud? Why people have been talking about cloud, especially the open source community have been saying that I want to use cloud. For example, let's take you go to a company and say that you want to you configure your project and deliver. They would say that, can you give me an open source? Why? They want to have their data in their own cloud. Please understand here, they want to have the data in your own cloud. So people are doing research or projects with IoT. What I would suggest is make sure that the data that you're working is put up on an open source cloud. So the open source cloud could be Hadoop, right? Or it could be Spark, right? Why are people worried about putting the data only on their open source cloud? Is they are worried about the security. If they go to a third party company and say that the data is on the third party company, then there's a lot of possibility for somebody to steal the data. Please understand here, there's a lot of possibility for the data to be stolen by some third party. That is why people say that if you are in cloud community, please set up a open source cloud and push your data to the open source cloud, right? Now, when you push it onto the cloud, okay, is cloud going to be a facility just for data storage and management? No. Cloud has given a very interesting concept of something called as MapReduce. MapReduce. I'll show you MapReduce concept. Then I'll walk through an example of how MapReduce can work on an IoT data. Now, please listen, all of you. When you have an input data like this, right? This input data has got 2 notations. One is K and next is something called as V. Please understand, one is K and something called as V here. So how does this happen? Please look from here. The input data that you want to process is a file. So what is this file? I just have a data in an Excel sheet. I have a data in a text file. Fine. Whatever is the data that you want to process, that data it needs to be processed by using a cloud. That's our first question. Are you getting? We want to process our data using a cloud. Fine. So when you want to process your data using a cloud, you want to first split the data, right? How will the data splitting be happening? It will be happening based on this HDFS, Hadoop Distributed File System, right? So once you give your data, the data is going to be splitted, right? So here, for example, it's splitting into 5 halves. So it's 0, 1, 2, 3, 4. Now, if you ask me a question, what is there in the 0 to 4? It's a way of partitioning the data which you are given as a simple input file. Now, once this data is given to the worker node, right? The worker nodes will coordinate with the master nodes, right? And it will write the equivalent output at the end of all operations. So equivalent output here is the reduced file. So if you got split 0 to split 4, here as such, you're getting 2 worker nodes, right? So you'll have one output from worker node 1, which is output file 0. another from the second worker, which is output file 1, right? Okay. Now, if you go now to the top, you will start asking a question. Okay, what now my data is a file. So what is this? So you see three operations: map, combine, and next is reduce. Map, combine, and next is reduce. So yeah, open source cloud, especially Hadoop, gave a very interesting concept of something called as map reduce. It said that you have a data, don't worry about keeping the data as a data. Instead, I will just reduce the data for processing on the cloud. So you'll have map, combine, and you'll have something called as reduce. Now, let's see this with a small example here. If you have a file like this, the file is like this as a text. So that's one more file. This is similar to a file that you are seeing here. Please understand here. Please listen, participants. We are having input files. So we have two files here calling itself as file 1 and next as file 2, right? Now, let's see what your map, combine, and reduce is going to do. What map will do is map will actually try to create individual maps for your individual files. So how many files are there? File 1 and file 2. So file 1, it creates a map 1. File 2, it creates a map 2, right? Now, what will be there in the map is, it will just say the value, right? Along with the key, right? So here as such, it is key value, right? Okay. So yeah, cloud here will start saying that my data I'm going to process, I will process it as key value pass. Now let's see how it does. So it says hello 1, world 1, hello 1, and it'll say moon 1. I hope you can understand here. Now come to a second map. How will your second map be look like? Goodbye space 1, world space 1, good night space 1, then moon space 1. Okay, now map is done. Now what a combine will do is, a combine as such will try to go for the occurrence of the same content. Wherever it is occurring, it will sum it. For example, hello, if you can see here, is occurring 2 times. So hello space 2. Moon is occurring 1 time. So moon 1, world 1, right? The second map, there's no combined effect because everything is unique. Now reduce as such, what it will do is, it will try to combine both of it together. Now just see here what it will say. Moon, if you see here 1, here again 1. So it says moon 2. World 1, 1. So world 2, right? Then similarly, hello, it's 1, 2 here already. So hello 2. So goodbye, you'll have 1. And good night, you'll have it as 1. Right? So this is how your mat, combine, reduce will do, right? Okay. Now, you go from the programming perspective, it will be very simple because if it is a Java, if you are a Java developer, you will use the same code, right? In this code, you will actually set the class name. So class name will be word count, right? And you will set the jobs, right? So for the jobs, you will set the file path. File path will correspond to the program file paths. And then you have already a class called as mapper. So you'll create a new class called as map, which extends the inbuilt class called as mapper. So what is the purpose of the mapper? Mapper as such will just convert the data into key value. Please understand, mapper will convert it as key value. So from the given text, we have converted as key with value. So now we got key with value, right? Now your map is completed, right? Okay. Now, when you go for the reduce, what is reduce going to do? Reduce as such is going to take the input from the combine. When it says moon, it will see in the second map also whether there's moon. Yes. Now it will sum this 1 plus 1. So it is 2, right? So that's the purpose of reduce. So this will be the code for your reduce. So for reduce, we have already an existing class called as a reducer. So public class reduce extends reducer, right? Within that, what we do, we try to find the common values. We try to sum the values. Can you find here? Sum equal to sum plus val.get, right? Now, this is the final that we have been trying to say. We got data from 2 files. We created maps. The map is created individually for the individual files. We then do the combine. Then we did it reduce, right? Now, a layman's question somebody would start asking is, all this is fine. Okay, when you talk about your data, all this is fine. But how does this actually takes up for an IoT data, right? Somebody says, I'm looking for an IoT data. How does it look like it, right? Okay, so let's take through an example. 1 minute, I'm sharing the screen. Okay. Any questions from the participants? Participants, any questions?
Participants, if you have any query, please interact with sir.
There's no questions, you can put no, at least we are talking virtually. Okay, fine. I'm not getting any questions. Okay, now the next would be is like people will be interested to know, okay, how do I take my IoT data, and from there, can I actually look at how can I do my cloud processing, right? Okay, now that's the second question you should have in your mind. So let's take an IoT data, right? Now, if you look at the IoT data, there are a lot of data that's there on the internet, right? Okay, so I will go to IoT data, which is there for smart buildings, which is there in Kaggle. Okay, you'll get this data, right? So very interesting data. This is a data which is there for smart buildings, right? Okay, smart buildings. If you look at this data as such will have all the inputs from different sensors. You can see here, it will have data from different sensors. So the number of sensors is 5, right? Okay, in this, the sensors, if you ask what are the name of the sensors, it is carbon dioxide, then room air humidity, then room temperature, luminosity, and then you have something called as PER, motion, sensor data. Okay, now I just give you a small feel of how this can be processed on with respect to a cloud problem, right? Okay, so please listen. If you don't get something, please ask. Now, this is our data that we have, right? So it's a smart building data, right? Now, if you ask a second question about this data as such, this data also has timestamp, okay, which is recording the data from the buildings. Now, why are we using this data set is to understand the physical properties of a room in a building, right? If you want to just see the physical properties of the room in a building, for that, this data set has been captured. Now, let's look at like this. Now, there is a timestamp. That's a timestamp. Now, let's understand how MapReduce can be tried on this data. So let's take this data here. So timestamp, carbon dioxide, room air humidity, room temperature, luminosity. Then we got something called as motion sensor data, right? Now let's come down to the map. Now this data is getting available as files. Okay, I think people understand this data is now coming to us as files. So what will be there in the file? Let's take, it says now it's 251. So time is 250. So carbon dioxide concentration is 12. Humidity is 23. Temperature is 100. Luminosity is 2. Motion sensor data is 5. Okay. Now it says 251, for example. So now as such 23, it says 12. It says 101. Then this says 5. This says 2. Right. Then 252. Okay. I'm just recording the data just for you to just get a feel. 23, 4, and you have 1. So let's take 253. Okay. So you say it's 24, then 35, and then you have 67, then you have 5, then you have 2. Okay. Now, given this data like this, which is recorded from an IoT application, our question is like, we are interested to do a map reduce. Earlier in the previous example, we did for a count of words, right? Count of words is very simple. But if you look at this here, people will ask a question, there is no counting required. So what can I do, right? So to answer to it, what I generally suggest to people is just find out what questions you would be interested to process with this data, right? What questions you would be interested to process the data. One, you would be interested to ask is like, which sensor had highest value, right? So which sensor would have a highest value, right? So that case, the answer people would immediately say is, it's very simple. You can actually use a max, right? If you just use a max function here, you can actually say in this row, right? The maximum is 100. In this row is 101. In this row it is 34. In this row it is 67, right? This is one type of question. Now, second type of question somebody would be interested to ask is in interval of, okay, in interval of your timestamps, right? Timestamp of 2, right? So interval of timestamp of 2, we are interested in finding what is the average sensor value. Okay, what is the average sensor value? Now, when you do like this, what you are trying to do is you are trying to have individual map operation first. So your individual map operation, how it will come up? It will start saying that it will give you the values. Now, if you take this one, this row, okay, so now you come to your map operation. So your map operation will say, this is 1, 1, okay, this is 1, 1. I'm not doing anything different. Please see, I'm trying to map the theory that you have learned. Okay, so the theory that you have learned is this. If you have 2 text files, okay, I'm trying to show you what will come up in the map, right? Okay, so here as such, the text files as such are, this is one file, okay, this is another file, this is another file, and so on. So now, if I look at the second one, it will be 251, okay, it will be 23, 1, right? Okay, so it is 12, 1, 10, 101, 1, 5, 1, and 2, 1, right? Now, if I'm going to give this to your next is going to be, I'm going to give it to your slave node, right? Because why I'm giving it to a slave node? Because the question is in the interval of timestamp of 1. Let's take it like this, not 2, 1. So it means 250, 251 together has an interval of 1, right? 1 minute, right? As intervals. So I want to give this together to slave node. So what is your slave node will ask is, what should I do as an operation, right? Because earlier we said that we want to do and count, but now the slave node will ask, okay, just say me what I should do, right? So there you are informing to the slave node that you have to do a combine, right? Okay. And you have to reduce it using what operation? Average, right? Using average. Now, what the slave node will do, the slave node will just take your data. So this is your data that is coming from the map, right? This is your data that is coming in the map, right? So you have to give only like this. Don't ask why and all, right? You have to say 12, 1 because this is key and this is value, right? So 23, 1, 100, 1, 2, 1, 5, 1. Similarly here also 23, 1, 12, 1, 101, 1, 5, 1, and next is 2, 1. Now when you try to do a reduce operation, now the reduce operation says what? You have to actually have the sensors values averaged. So 12 plus 23, right, divided by 2. So it will give you the value as 12.5. which is 25 divided by 2, right? This is 23 plus 12 divided by 2, 12.5, right? Okay. Now 100 plus 101 by 2, it will give you 100.5. Then 2 plus 5 by 2, 3.5. Then 5 plus 2 by 2, it is 3.5, right? So here you are done this operation of average because the data is demanding, saying that in the interval of timestamp of 1, just give me the average sensor value for all the sensors, right? Average sensor value for all sensors, right? Okay, now that is always possible for the problem to be very challenging. The problem might ask you one more question, right? It doesn't, it says that, okay, it is for all sensors is fine, right? But I also want to know one more thing with its max, right? With its maximum value. So when you say with its maximum value, now what you do here, you'll combine and reduce using average, and then you'll just give the max also. So the first part of reduce will actually do this, right? And the second part of reduce will actually say for this slave node, from this slave node, the max value printed from here is what? The max value is 100.5. Are you getting? Printed is 100.5. Somebody might ask a question, no, why it should be saying with its max, right? It can actually say the sensor with the maximum value also, right? Give the average sensor value for all the sensors and print the sensor with its maximum, right? Then that case, what it will do, the maximum sensor is value is 100.5 from the average, right? But the sensor name is what? The sensor name is 3, right? It will automatically go back and say room quality is the output. So it will try to say room quality. I hope people should understand, right? This is how your MapReduce works from the real time. If you have any problem, people always think about the word count problem for MapReduce. No. Reduce as such means it says that you can use different mathematical operations based on what you want to analyze from the data. In this case, the data is actually with respect to the sensors. What I'm interested to analyze is I want to find the maximum sensor value. It's very simple. Every row I can apply max, right? But sometimes people ask that in interval of timestamp of 1, that means what? I am taking these 2 records, right? Give me the average sensor value for all the sensors. That means I should do a reduce with an average operation. If the question is extended from the analysis saying print the sensor with its maximum value, then I should say what is the sensor name? So sensor name I can just identify and print it as room quality. That is room air quality. Participants, are you able to understand? This is how cloud actually uses MapReduce on a real-time data. The data that we are taking here is an IoT data here. Any questions? Any questions from the participants, please? There's no questions, please put no at least in the chat box. Okay. Stays calm. I believe that people are listening and you don't have questions. Let's move on to the next part. So our discussion was very simple. We want to take a data which is there and we want to apply your Hadoop concept and we want to say that MapReduce is possible, right? So that is now done. Now, the next perspective which we are sitting into is your big data, right? So data is big, data needs to be processed. This is always a question from everybody saying that my data is big data. I want to use it for my research. Yes, whatever may be the data that you have taken, right? The interesting question would be is like the data will give you some challenges. So that challenges will ask you a question saying that how much amount of data is certain, right? Certain, right? For example, if I have recorded your face in the beginning of the lecture, right? And then if you start seeing your same facial emotions over the time, okay, your emotions would have changed. Now, if I ask you a question, has your emotions been the same in the morning? Some people might say, no, morning I was very fresh. So my emotions were clean. It was very good. Maybe now my emotions are little not okay because I'm very tired in the afternoon. So there's a lot of uncertainty to the data. Please understand there is a lot of uncertainty to the data. Wherever there is uncertainty to the data, there you cannot actually use algorithms to solve. So there you have to develop learning models. So that learning models can be built on machine learning. Are you getting? That learning models can be built on machine learning. Now, go from here and start asking a fundamental question. If my data is there and I'm interested to classify this data, right? Whatever may be my data I want to work, I want to basically classify my data. For example, I have got a data set from my IoT application. Now, this data set is captured with time, as I told you just now. I got the features from the sensors. Now, the next question somebody would ask is, what can your model do with this data? The model as such can actually classify the data. What can be the classification? As I told you, this data set that we have taken, right, has given us an input saying that this can be helping us to understand the physical properties of a room in a building, right? So ideally, it is trying to give some classification saying how much is your room dense, right? How much is your room spacious, right? For example, people might usually be knowing that in your room where you're trying to have an air conditioner, right? If you have a lot of things in the room, no, the air conditioner will consume a lot of power. Reason is the air conditioner has to first actually make the room chill. But before that, it has to have some dampening effect with all the items in the room. If there are many items, all the items will consume, right, the chillness. So the air conditioner will take more time. So the physical properties of the room can actually be measured based on many factors, right? Now, leaving all that, our question is very simple. Now, whatever data that we have, right, whatever data that we have with respect to features, now with that features, is it possible to classify the room? That's a question. If you want to do like this, it means that you got the features from your different sensors. Now, given the features like this, your question is you want to classify the data. There, you will classify the data into different class labels. If you want to do this, you have to take the help of unsupervised learning. So there, people use an algorithm called as K-means clustering, right? People use an algorithm called as K-means clustering in case your data do not have class label. Like for example, we have taken a data set of smart building, right? Now, if you go down and see the data set, if it does not have any class label, right, then that case, you can assume that this algorithm that you'll be choosing is an unsupervised learning, right? But if you can see here they are supplying two type of classes. One, they say the data set is suitable for both supervised model and also unsupervised. Are you getting? So you can either use an unsupervised or supervised. Now comes the question, should I use unsupervised? If your data do not have a class label, like for example, there is a class here, but there is no class label at all for the class. There, what you have to use is an unsupervised learning. Please listen, all of you. If you have a data from your sensors in your IoT application, you do not have a class value at all, you will have to go for an unsupervised learning. The other way around, I have data in my class label, so I can go for a supervised learning. Are you getting? So there is already a training data which is well classified. So I'm just trying to use my test data, right? So my test data will allow you to predict the class to which it belongs. There, what you're falling in is something called as a supervised learning. And in unsupervised, the algorithm you'll be using is a K-means clustering. And in a supervised model, the algorithm you'll be generally using is K nearest neighbor. The other algorithm which you'll be generally using is a kernel-based approach, which is support vector mission. Okay, so this is KNN, that's K nearest neighbor, and next is something called as support vector mission. There is also another choice. If you feel, no, I don't want to use conventional algorithms on distance-based or kernel-based. I would like to use algorithms which are basically on probabilistic based. There you can actually choose Bayesian classifier, right? You can also use Bayesian classifier in case you want to go for a probabilistic approaches. Now, sit around your data. Now your data that we have taken is an IoT smart building data set. This data set has got some features. So if you do not have a class, again, I'm insisting, please use k-means. If you have a class, then you can give the test data and you can predict the class to which it belongs, right? Okay. Now, this is a place where the data is captured and is available. We are using models to predict the classification of the smart building. Now, is this data going to be a big data? Yes, people will accept with me. The data is captured with time. If you're going to capture every minute, then it means 1 hour, 60 minutes, right? 60 records. Every second, then it is 60 into 60, right? If it is milliseconds, 60 into 60 into 10 power 3, right? So if it's going to be 24 hours into 365 days, see the data becomes larger, larger and larger, right? So this is where your data will become big data. So time is a very important feature for any data because it can make that data from smaller size to larger size, right? Now, keeping this as input, let's go into the next part of discussion. Our next part of discussion would be is to understand how this can actually work with k-means, right? As far as k-means clustering is concerned, the concept of k-means clustering will say that you need to compute something called as a centroid, right? So what is a centroid would be, you can call it as a mean, you can call it as a centroid, right? Then after you compute the centroid, you can find the label for the training data, right? So you give the label for the training data, and with the test data, you will be able to find what is a class to which it belongs. Now let's see how it does. Here there will be two steps. First step would be data assignment step. What is data assignment step is, here we use a formula like this. Argmin dist within bracket c suffix I comma x. Now c suffix I is basically the set of centroids. X is your data, right? And here the distance that you'll be using here will be generally Euclidean distance, right? So c suffix I is your centroid and x is your data and dist is nothing but your Euclidean distance. Now this is data assignment step. Now let's see how it happens here. Now, this is the other question people ask, like, okay, now you say you're giving data to the model, right? The data can actually separate the building data into many classes. It can be saying C1, C2, C3. Somebody will say, no, C1 and C2. So what is the value of K that you can fix? The value of K that you can fix can be minimum as 2, right? Because it is a multi-class problem. Compulsorily, you will have at least 2. That means there are 2 classes, class 0, class 1. Or if you want to find the best value of K, there you can actually use this algorithm called as an elbow method, right? You can use this algorithm called as an elbow method. If you go to the internet and type elbow method, you will get a good algorithm for elbow method, right? There's different elbow method coming, don't worry. Elbow method k-means. Okay, so this is your elbow method. So this method as such will allow you to say what is the value of K that you can fix. K corresponds to the number of clusters, right? K corresponds to the number of clusters you have used to your model, right? Now, let's see how does it do. How does your k-means does it? So k-means as such will ask you what are your features. Now, if you look at your data set, you will agree with me saying that this is all features with my sensors. This is my time component. So I will give all this as features to my data, right? Let's walk through for one example, then you'll be able to understand how does your k-means work. Now in this, if you can see here, this is your input samples. So there are 2 features. Feature 1 is X, feature 2 is Y, right? Now you're giving K equal to 2. When you give K equal to 2, what does it mean? You want to create 2 classes. The building data is categorized into 2 classes, class 1 and class 2. So here we are calling it as something called as cluster, cluster 1, cluster 2. That means K1, K2. If there are going to be 3 clusters, you call them as K1, K2, K3. So you need an initial centroid. So you can take the initial centroid to be temporarily as first and second. So the initial centroid for the first class is 185,72. Initial centroid for the second class is 170,56, right? Now what you have to do, you have to find the distance of this data to the individual centroids. But that's a formula that we saw, right? Argmin of C suffix I, comma X, right? So your centroid 1 is this 185,72. Find the distance of it to all the other elements. So when you find it, you will go for an Euclidean distance. So what is the Euclidean distance formula? 185, minus 170 the whole square plus 72 minus 56 the whole square, right? 185 minus 168 the whole square plus 72 minus 60 the whole square. Next, 185 minus 179 the whole square plus 72 minus 68 the whole square. Similarly, 185 minus 182 the whole square plus 72 minus 72 the whole square. Last, 185 minus 188 the whole square plus 72 minus 77 the whole square. You will get a set of distance values. This is all distances with respect to cluster 1. Now you have to do it with cluster 2. Cluster 2 distance centroid is what? 170,56. Compare with the rest of it. 170 minus 185 the whole square plus 56 minus 72 the whole square. 170 minus 168 the whole square plus 56 minus 60 the whole square. Like that, you do for all the 4. Once you've done it, you will get your distance values coming up like this. Now, what you got finally is to know that your input data is available. And now what you have done is you have calculated the centroid of the data, right? And you have got the distance with respect to the centroid. So with respect to C1, the centroid, C1 is originally 185,72, right? When you compare it with the data, it will be 0. When you compare it with the second centroid is what? 170,56. It is 21.3. So for each samples, you will have to pick the centroid which is having the lowest distance. So for 1, it is cluster 1. Second row, cluster 2. Third row, cluster 3. Sorry, C2. And fourth row, C1. Fifth row, C1. Sixth row, C1. Now, the data as such that you've chosen is now classified. Are you getting? Like what I told you, you have your data like this. We gave the class label. How are we getting the class label is? We get the class label like this, right? Based on your k-means. Now, once this is done, then the first step is over. What is the first step? Data assignment step is done. Now, the second step that we have to go through is something called a centroid update step. What is centroid update step is? You have done for one iteration. At the end of iteration, the cluster values have been presented. Now, how do you fix your centroid? Can you assume that the centroid is right or can we modify? That's the second step. So there, people go for a centroid updation. How is centroid updation being done is, you look for all the class labels which are 1. What are the values? 185,72, 179,68, 182,72, 188,77. Now you do the average of all the 4. What will be the average? 185 plus 179 plus 182 plus 188 divided by 4. So your average will be 183.5. Similarly, you do for the Y with respect to class 1. Similarly, you take for class 2. You will get your new centroids, right? Now, what you're supposed to do, this is your new centroid. Now you have to take all the data individually, right? And you have to check what is the distance of that individual rows. Individual rows means what? 185,72 with respect to 183.5, 72.25. This is a new centroids, right? And you will have to find the cluster distances. If the cluster distances have been computed, then you can assign the clusters. There, people usually ask a research question. How do you decide that it is correct? Okay, should I again repeat? If the number of clusters have not modified, for example, in iteration 1, we got 4 samples to cluster 1, 2 samples to cluster 2. Second iteration also, I got like that with the new centroid. You can stop it there. Is it okay? Or the other way around would be simple. Here, if you can see here, the number of instances falling into C1 is 4. Number of data points falling into C2, right? With the sensor data is 2. So it is 4,2. It seems to be very high. Cluster 1 is very high. Cluster 2 is low. So what is the answer? When you try for the second time with the new Centroid, you got lower data points to C1 and lower data points to C2. You can actually select the second step. Is it clear? So this is how K-means can be used for an IoT sensor data to classify the nature of the building that you work, right? Okay. Now, next forward would be like people actually ask a question, okay, all this is done with the training. What about your testing? So in testing, what we do is actually is very simple. Testing, we actually use a KNN. That means we use a K nearest neighbor algorithm. What does KNN will do is, KNN as such will actually try to find the distance of this, right, test data with all the individual training data. For example, this row is your test data, right? You don't have a class label. Now you compare with all these rows. Are you getting, how do you compare? 12 minus 23 the whole square, 21 minus 2 the whole square, plus 8 minus 34 the whole square, plus 7 minus 2 the whole square. You get one value, right? Let's call the value as A. Okay, right? Now, next what you'll do, you'll take this, you'll compare it with the second row. 12 minus 23 the whole square, plus 21 minus 21 the whole square, plus 8 minus 21 the whole square, plus 7 minus 2 the whole square. You get a value, let's take, we call it as B, right? Like this, you'll get values for all the 7 rows. Whichever is smaller, right? For example, this row, you got a smallest distance, right? That means I compare 12, 21, 8, 7 with 12, 3, 4, 2. I got a smallest value, right? There I go and look for the class label. Class label is 1. So I can give the class label here as 1. This is how your KNN works, right? K nearest neighbor works. So ideal research would be in an IoT based data problem like this is to use K-means for finding the class label in case there is no class label at all. Once you've done the class label, then you can use a KNN and find the class label here. This is called as prediction. So this is classification and this is called as prediction here, right? And most of the times people actually suggest to go for regression itself because it is possible for you to use a linear or logistic regression also to classify the type of class to which your building data is falling in, right? Okay. Then this is the next type of classifier that you should know, which is called as Adaboost Classifier. Okay. Adaboost Classifier. 1 second. So where will people go for an Adaboost classifier is, there are a lot of possibilities when the data is coming in and it's getting processed. It might land into something called as outliers. Outliers. Okay. What is an outlier is? I'm giving a test data, right? It is supposed to fall into this class label here in this IoT smart building data problem. But actually it's not falling in. It is not falling into any of this. So that becomes an outlier. So there people suggest that you should go for some other algorithms. There one answer would be is to go for a Adaboost classifier. Adaboost is a very good classifier to evaluate in any models, right? And the next important thing is Adaboost classifier can be used to handle the problem of overfitting of data, right? So sometimes what happens is when you give a new data, the model as such will not predict at all, like what I told you, right? Okay, and let's take, I give a similar data. For example, just that visual thought, if I give 9, if I give 3, you can keep this data as reference, okay? 9351. You will say, surely it will classify, but there also it is not working. Are you getting? That means it results in a model not having a good performance. So there, one possible solution is to go for a Adaboost classifier, right? So if you have an IoT generated data, like I shown you for a Kaggle smart building data set, you can very well classify the data set and predict it. But when it results in any sort of outliers problem, please use Adaboost classifier, right? Please, you can use with the Adaboost Classifier. One second. One second, I'll share you the code environment. But if there's any questions, people can ask.
Thank you, sir. I request the participants to raise queries. Participants can raise queries by unmuting yourself, or else you can use the chat box to pin your queries.
Good evening, sir. I am Ramakrishnan from Sakti Polytechnic College. It was well presented.
Yes, sir. Good evening, sir.
Sir, it was well presented. Very happy, sir.
Yes, sir. Please, sir.
Can the students do some agriculture related products, sir? Where can we get these sensors and data, something like that, sir?
Okay, sir, as much I know, actually, if you're working on agriculture relevant project, you'll have to build your own test bed, right? So ideally would be like you can get an Arduino board and you can actually configure it with sensors for temperature, moisture. You can measure temperature and moisture, sir. Okay, sir. And humidity is also generally measurable. And I think to my knowledge, actually Roots is working with some projects with agricultural monitoring. Roots company, they work with agricultural monitoring. So maybe if your students can actually try to send a mail through you to the Roots manager like that, they will generally advise to do such projects. And I have seen recently with PSG Tech that they have sponsored for the hardware part. Okay, sir. So Roots is into irrigation planning, sir. So there you can contact. That is one source. Then second source is, sir, you're able to hear, sir?
Yes, sir, certainly.
Yes, sir. So Roots Industries, Coimbatore, sir. Then second is you can try to contact with agricultural college, even Agri Coimbatore, because there I think people know that, like we say BSc Agri, they have engineering Agri, where they have got wireless networks courses. There also they have got some small setups of data aggregation, data collection and all that they're doing. So there you can get some data set. This is second. Third, I shown you in the beginning of the presentation an open source website, right, on the internet from Government of India, where they are trying to show all the climate data sets, CCAF. Yes, there you can get. And next forward is you can use this organization also for support. I'll just show you that also. 1 second, sir. Okay, I'll share the screen maybe. Yeah. So there's an organization called as IGCAR, right? Indian Council of Agricultural Research, right, sir? So they also work more into agricultural aspect. Okay, I'm Indian Council of Agricultural Research. Okay, they also completely work on agricultural research. So one possibility is like you can contact them. They also source the data, but only thing is they follow through some IP issues. Okay, here there's a person works more active in this area, Ravichandran. Yeah, correct. So you can see the website now. So he is more into rice research, and I have good rapport with sir actually, and he's a senior scientist, and he responds to communication. If you write a mail, asking for some sort of association to work with agri data set, generally sir guides and suggests for discussions also. And he visits Coimbatore also for some discussions to the forest institutes, Indian Forest Institute. Is that okay, sir?
Great, sir. Great informations. If any such thing arises, let me contact you also, sir. Thank you.
Yeah,
Sir.
sure, sir. Please contact me and you can send a mail to sir. Sir knows me also. And as much I know, sir responds immediately to the queries. Okay, sir.
Okay, sir. We got a specific course called Agriculture Technology in our Polytechnic.
Very good, sir. Very good.
Only in our Polytechnic we got that as
Then I think he will be a very right person, sir, for you.
Yes, sir. We will do it.
PhD in agricultural statistics, right? So I think he's nice and he's got vast knowledge in statistics and he works on more of rice paddy cultivation and he's got data also. Your question was data, right? He's got data also. Only thing is official things you communicate properly, sir advises on how to proceed.
Great, sir. Great, sir. Thank you very much. Thank you so much. Thank you so much.
Sir, a query from Prabhakaran, sir.
Yes, sir. What is the query, sir?
My another question is this much development in good for human community?
Okay, the whole world has global rights, sir. I'm not a very good person to talk on human values, but as such, if you ask, should we give phones today to the kids, you'll say yes only, right? So same answer here, sir. We need monitoring of data for many reasons. I think people would know that, let's take you talk about social media, for example. A coincidence, I'm just answering. Social media is just for networking, communicating, chatting. And there are a lot of cases we come across saying that social media is leading to a lot of distractions. But I think you would have heard like I think 1 year back, right, when one of the when one of the person was kidnapped in the north, right, and was not traceable. They just put up in social media and less than some 6 to 7 hours, that person was saved, right? They were able to find the visibility of the person where the person is. So it is like that, sir. So both sides are there, good and bad, but we will look on the good side, sir. That's my answer. Sir, have I answered to you?
Prabhakaran, sir, I think you might have got your answer. Is there any task that cannot be linked with IoT?
Is there any task that cannot be linked with IoT? See, wherever you can actually measure data through a device, there you can actually bring an IoT problem, sir. That's all. Right, but the challenges are always there. For example, I basically in my PhD and after my PhD, I work on video data with my scholars. For us, if you have a camera, anything that you can do with the camera is an IoT based problem. Right. For example, you can actually use it to track humans, you can track animals, you can track fishes, and so on. But if there is a challenge that is there, one challenge would be is like, how are you going to build the data? It is very simple to say that the video can be captured, right? But pushing it onto the cloud and retrieving it back for your model will be little difficult. So there you will surely have some challenges, sir. I think that can be an answer to your question. Is there any task that cannot be linked with IoT? Yes, building an IoT problem becomes challenging when you have difficulty in generating the metadata with your given problem. Prabhakaran, sir, have I answered your question? Thank you, sir.
Thank you, sir, for being with us today.
Yeah.
You have given some informative sessions, sir.
Yeah, 1 second, sir. Going forward, I would like to show one quick output and then I will finish it in the time, sir. Please.
Sure, sir. Please.
So this for people to just get a quick feel. Usually when you want to implement any applications which is based on IoT or IoT data processing, Python will be a good environment. And here we generally suggest people to go for Anaconda. Anaconda is a good software for you to work, right? You can use Anaconda for working. If you go to internet and download Anaconda, you'll get Anaconda. And code, you can write it using Python. Right? Code, you can write it using your Python dataset. So I'll just show you a quick output of what happens when you are trying to use all this machine learning algorithms. Now we said that we have some data from our smart building and the data is downloaded, right? And it is available for us. Now, once the data is available, then you can actually do some analysis on it. So if you're going to implement a code for it, the code will be in Python. So the code as such will start saying that I need some packages. This is all packages. If people are new to Python, they would say that this is all packages. In this, a quick thought would be like, show me machine learning. Then answer would be like, we are using a library called as sklearn, right? From there, you can actually import this algorithm, which is k-means, right? So k-means will be for training, right? And next for testing the data, that's your smart building data. You can use knn, that's your k nearest neighbor. So sklearn.neighbors import k neighbors. Then whenever you want to evaluate your model, use some metrics. So the metrics can be precision, recall, accuracy, all this can be metrics. So first you are loading your data, right? Data is your smart building data here. The next step is you're calling k-means and you're finding the class labels. So we did through mathematics, right? That program will do immediately. Only thing is you have to specify the number of clusters. How many number of clusters, it is dependent on your problem. You can use an elbow method and say how many clusters you want to follow in your data. So here it has found the class labels. Once it has found the class labels, the next step is I want to do the testing, right? Given a test data, I want to run knn. So knn, the neighbors will be tried, right? So once you run your knn, it will actually run through, it will start showing about your output. It will say how many total number of data is there, how much amount of data is used for training, right? How much amount of data is used for testing, right? So it is a rule that 70% of data you can actually use for training and 30% of the data you can use for testing, right? In your given data, right? So next what it will show is like it will predict the class. This is a predictor class with k nearest neighbor. Please listen, all of you. 5 minutes I'm completing. So this is a predicted class with knn. Now this is the actual class that is found using k-means. Fine. Then next step, what we do here is we come down and prepare the metrics. So usually the question is like people will say that I was able to find the class label. Is it correct or not? Answer is you have to print the confusion matrix. So confusion matrix is a very good metric here. So an ideal confusion matrix will say that you will have values along the diagonal. So that means above the diagonal, below the diagonal, you should not have values. But here, this are all misclassifications. I hope people can understand. This are all misclassifications. So what does it mean here is a simple thought process here would be like this. A class label which is supposed to be 0 is misclassified as class label 1. How many? 6. A class label as 0 misclassified as 2. How many is misclassified? It is 5 in here, right? So you can use a confusion matrix to understand how much your model is correct. You have done k-means and knn, whether it's correct or not, you can use confusion matrix. Along with this, there are other metrics like precision, recall, accuracy, F1 score, support, which you can use in your research also, right? This is one quick thing which I was interested to show. And second thing is a small output, which might be a quick thought process to the people. Okay, so I'm sharing the screen. Okay. See, with the projects that we are working with, actually, we have some outputs which will be related to your IoT concepts that we are discussing today. One application that we are working with is actually on the human activity monitoring, right? Let's take somebody is inside the room, right? And the camera is actually picking up the data. Is it possible for you to find out whether the person has fallen or not? Right? It's a very important requirement for today, right? Because anybody gets a health problem and they fall down. So this is most vital when you're looking for possibilities of people who are staying in home, right? Especially the older people, you know, when they stay in home, they find it a lot of difficulty to monitor, right? You cannot keep one person to monitor the age people always. So there, what is the requirement is we are in a position to monitor the people. So there we need to monitor the humans. And second thing is like whenever we are interested in monitoring, we want to classify the type of activity, right? So this is this understanding is the camera is actually the data, and with the camera we want to do some processing. So the classification we want to say is whether the person is fallen or not fallen. Assume the person is walking down, right, to the room, and assume it is person is falling down, right? Here there's some algorithms running, right? Machine learning algorithm here. But actually we have used this deep learning also. So this automatically finds that the person has fallen and says that the person has fallen, right? And once a person gets up after some time, right, then automatically it will actually try to say that the person is not fallen. Right? This is an activity classification problem in IoT application, Internet of Things, right? And this is one which I want you to show. So next one is slightly different. This application has got a different requirement. If you have tank with fishes, so the usual thing is like, this is for one of the professors. So his requirement is he has a big fish tank, right? And whenever he wants to put the fish food, all the bigger fishes come to the top and take the water. So what happened to the smaller fishes? So can I find the area and see how many big fishes are coming to the top? And based on it, can I increase the amount of food, right? It's an IoT problem. So here what we are doing is we are using some other algorithms for tracking the fishes from image processing, right? So going forward, in summary, what I was interested to present to you all is about a quick thought process of how all the cloud, IoT, big data concept can go together, right? Forward, if you have some any questions, please write me a mail also, and maybe in further, if something to be clarified, please let me know. Thank you so much for the opportunity being given. Thank you, sir.
Thank you, sir, for accepting our invitation, and you have given your best. And the program, I mean, the session was quite informative and fruitful, sir. Thank you for being with us throughout 90 minutes. On behalf of GRG Polytechnic College in Instrumentation Control Engineering, we render wholehearted thanks to you, sir. And you have been with us since the last HTTP also. So thank you for your support throughout the session and the program, sir. Thank you, sir.
Thank you, sir. Thanks to you, sir. And thanks to Indra Devi, ma'am. And thanks to the campus. A pleasure. Be safe, all of you.
I'll convey, sir. I'll convey, sir.
Yeah. Thank you, sir. Thank you.
Thank you. Thank you, sir. Thank you, sir. Participants, kindly fill your valuable feedback. The feedback link has been posted in the chat box. Please find the feedback link and then post your valuable feedback. So I request all the participants to rejoin in the day 6 program by Monday morning at 9:15 a.m. Thank you.
Thank you, sir.
Thank you, sir. Thank you. Welcome, sir.